All right, so welcome everyone to the second session of week 4. Um, and first of all, just a quick recap, everyone for their attention. Quick recap of what we did in the last session was series of transformations which we did with formula in data IQ. We also looked at the sampling where we said, you need to look at the sample versus the population in order to make sure what data IQ is looking at. I hope you will get a chance to practice this later. Okay. The only thing that you need to do is whatever we are doing in class, just find time, half an hour, 45 minutes, other than the class. Repeat whatever we have done. Make sure you're comfortable with formulas. Make sure you're comfortable with treating missing values. Make sure you're comfortable with prepare recipe, data transformation, etc., etc., and you are comfortable with data IQ. Last class, I've already mentioned about the coursework, which is the hackathon as well as the main project that you will be doing. And if there are any questions before I tell you the agenda for today, please let me know. All good over there? We don't need it right now, so all okay. No need for data IQ today, so I'll tell you what the agenda is. So any questions? Any questions anyone has for the module, for anything that we have covered? Yeah. Did we record the last session? We did record the last session, yes. Even this one is being recorded. Yeah. Anything else? Anyone? All good, shall we proceed? Yeah. I heard so, yeah. Probably not, because I tell you, I think the hackathon which is being planned is mainly for the use of AI tools, which means, all the new AI tools which are there, how to use it, how to build, let's say, a website using Claude and things like that. But probably not much related to the actual AI algorithms and actual AI development. So I heard from Mariam, I think that you have something on Friday. But yeah, again, that's something which is added on as a value, whatever you learn, it's already good for you. Anything else? Any other questions anyone has?
Have they answered the recording?
So recording, by the way, for those who have only attended on campus and have not attended online, just to tell you, this is how it looks like, the channel. So if you look at lectures and seminar channel, you see every meeting link is a different one. We haven't recorded everything, but for example, if you want to see the last one, come in, which is, let's say 23rd June. Yeah, there you go. So 23rd June, if you see the chats somewhere here, there you go. So that's the recording. So just click on the link, you'll find the recording. Okay. Great. So agenda for today is, as you know, starting next week onwards, we will be starting the 4 algorithms of the AI modeling. So next week, we'll be starting with logistic regression. We'll move on to decision trees. We'll be doing unsupervised learning, etc., etc. So before we get into the series of AI algorithms, today we will look at something more fundamental. And that's why I was saying we'll take a break from data IQ. And we will focus on regression as a method, which officially is not part of the module, but then I want to make sure that you understand regression so that we can actually go for AI algorithms like logistic regression and so on. And fundamentally, it's very, very important to know regression as a base method. From a prediction point of view, from a forecasting point of view, it's important to know this algorithm so that all the other algorithms you will do subsequently. Do remember, regression for today's session, we will use only Excel. Everything can be done in Excel because I fundamentally want you to get stronger on the algorithm. And then next algorithm onwards, we implement everything from big data, please. Okay, so you don't need data IQ access for today. And as I said, probably the last week for the foundational elements. So we actually start with the algorithms next week. The first one is not All right, so if everyone is ready, shall we get started with regression? Yeah, right. Now, what I want you to get prepared with is just have Excel on your PCs. Data I will give you later. I will first do some explanation of the algorithm. Then I will give you data. Then you will have your own time to do it. And then we will just go on increasing the complexity of regression. And at the end of the session, there will be a forecasting challenge, which all of you will be attempting. You will see who is the best forecaster in house. So that's where we are building up to. We'll start small, we'll increase the complexity, we'll understand the tips and tricks of regression, and then we'll head on to the final forecasting challenge. Okay. All good there, Sorry. Yeah. Sorry. If what is not possible? Okay. Only I think there are a lot of PCs which had issues. We are planning to change the menu. You can use today, it's just Excel. Yeah. As far as you can access my learning, then today you don't need Excel. Okay, so everyone, let's get started. I need your full attention. Excuse me. I need your full attention. And please, while I'm giving the instructions, if you keep on talking, then I have to raise my voice to neutralize yours. You're still talking for me. It is really a pressure on the throat. So please be considerate. And when I'm talking, at least you can be quiet. Then whenever you find an opportunity, you can always talk. Okay, let's get started. I want 100% attention here. You're not doing anything on your screen. You will get your opportunity. You will be given data. You will do it on your own. But as of now, just focus here and answer the questions step by step. Okay. I'm starting with something on the screen where you see day as one of the columns, day 1, day 2, day 3, day 4, all the way till day number 8. I'm going to put up some sales data. Don't curse me for it because you would never see such amazing sales data, but good to start our discussions around that. And I'm taking you from the fundamentals all the way till the expertise level when we think about regression. So here is the data in front of you. There is a company which is recording sales data. And as I said, in a realistic world, you'll never find 2, 4, 6, 8 kind of data. But let's assume that's the case. Let's also assume that nothing else in the world is affecting sales. It's only day and sales. There's no other variable which is impacting your sales in this firm. A very simple question to begin with. If you have to predict what is the sales for day number 9, what would your answer be? Very simple. Welcome. You already know regression, you already know forecasting. So that's a great start. Let me complicate a bit. What do you think is the predicted sales for day number 31? 62. How did you get that? Multiple of 2. All right. Now let's slowly build it from there. Let's assume the day is represented as X and sales is represented as Y. Did you draw a relationship between X and Y? What was that relationship? Y is 2 times of X, right? Which means put any value of X, double it, you will get the value of Y. Welcome to regression. This is exactly what regression does. It looks at your data, it learns from your data, it tells you a relationship between X and Y, or if there are multiple X1, X2, X3, X4, and Y, whatever. In this case, there is only one X and one Y. So it understood the relationship between X and Y, and you were able to do it yourself. That means at this point of time, you do not need regression. Mentally, you are able to assume and see the relationship. Few more questions. This activity which we did right now, where I gave you the data, you gave me the relationship, and you said y is 2 times x. Will you call this pure AI or is this machine learning? Machine learning, 100%. Can you tell me why? This is not pure AI. Why? What? How do I confidently say this is machine learning?
There's a formula.
There is a formula, but then, yeah, that is a valid argument. More importantly, if you connect back to last week or last week's session, what I told you, there is one difference between machine learning and pure AI. Pure AI works with intuition, if else, if else, if else. Machine learning works with data, historical data, and you actually, all of you, what you did right now, you assumed the role of a machine. You learned from the historical data and you came up with a relationship and you found the relationship and you said, look, y is 2 times x, put any value of x and get any value of y. Okay. In fact, what you actually did is machine learning. Next question. When I asked you what's the predicted sales for day number 31, you said 62. This activity, is it supervised learning or is it unsupervised learning? Why supervised? There is only one variable that you are interested in. What were you interested in predicting? Sales. That's it. Every other variable, which is day number or if there were other variables, they are all helping me predict that one variable of choice, which is sales. And that's why it is a classic case of supervised learning. Great response so far. When you came up with the equation, just focus now, and then you'll get a chance to do. When you gave me the equation, which is y equal to 2x, what do you think is the independent variable and which one is dependent variable? X is independent and y is dependent, right? It's pretty straightforward. Why do we say that? You can put any value of x, which means x is independent. X can take any value. X can be 1, x can be 30, x can be 40, does not matter. But depending on what value of x takes, y will be 2 times of x, right? This is all fundamentals of regression. In fact, regression helps you get that equation, understand the relationship. Right now, you did not require the help of regression because mentally, it was good enough. You could assume, you could see the relationship, and you could come out with an equation. So far, so good. Machine learning, supervised learning, because there is one variable that you are predicting, and the result of the learning is in the form of an equation that can connect x and y. All right. Shall we complicate this data a bit and see if you're still able to do it? Okay. Now what I'm going to do is this. Okay. Now listen to my question. Let's see who is the smart one here. Can you tell me the predicted sales for day number 30? 63. Interesting. Anyone else? He says 63 without dragging or doing anything on himself.
Take the question which number?
Day number 30. What is the predicted sale? 63. Tell us, Aisha, how 63?
Because it's more 2x plus 3.
Wonderful. I usually get that quite late, and people generally fail to get the relationship between x and y, but that's a great job. Y is 2 times x plus 3 is the underlying relationship. Check it out. So 2 times 1 plus 3 is 5. 2 times 2, 4 plus 3 is 7. 2 times 7, 14 plus 3 is 17. So if you just do 2x plus 3, that's the relationship between x and y. And I asked you for day number 30, which means 2 times 30, which is 60 plus 3. Good job, both of you. Fantastic answer. 63 is the key. But you saw what happened right now. In the earlier case, everyone jumped with an answer, and when it was only double, when slightly things became a bit more complicated, then it was difficult to formulate the relationship between x and y. Let's make it more difficult. And now let's check what's happening. Okay, now forget about day number 30. Just tell me what the predicted value for day number 9. I've just changed the data, and this is more realistic. 2, 4, 6, 8, 5, 7, 9 will never be a realistic sales data.
34.
34. Okay, any other guess?
35.
34, 35. Okay, let's store all these answers because I also don't know what the answer is. We'll have to do it.
37.
37. All right.
45.
2x plus.
But the ninth day,
Yeah, no, I mean, were you able to find the general equation first of all? What is that equation?
it's like for every day it's different.
That's the problem. And that means if I can't have a generic equation, how do I put the value of x and how do I get y?
There's no
But
equation.
there will be, that's where we come coming to. But let's take more guess, any guess from this side, take a guess now. What do you think will be for the 9th day? We'll do it. What is the most likely prediction for day number 9? Any guess? Throw any numbers, whatever comes from your observation of the pattern. Yes? Any number? Any number? Harsh? Can it be 24?
35 or 30.
35 or 32? Yeah, at least what I like is whatever guess you are taking, you are still following a pattern. You are seeing the numbers are increasing as the day increases. So, very less chance that suddenly it will reverse until and unless there is some external variable. And we already mentioned there are no other variables which are impacting sales. Now, everyone pay attention because this is where we are starting regression. Now, if it was humanly possible to find out the relationship between X and Y, you don't need algorithms, right? And this is exactly where machines come in. And this is exactly where algorithms come in. Now, the machines and algorithms are coming in and they are telling you, we will find out the relationship between X and Y. There are various ways of finding relationship. One of the fundamental algorithms which finds the relationship between your independent and dependent variables is called regression, which is exactly what we are going to see today. I will show you on how fundamental this regression algorithm has become that pretty much now every tool, every single tool that you work on today has regression stored. And it has become so basic that you will understand where all regression is actually done, but you never realize that at the back end there was a regression which is happening, and we will reveal as and when we go forward. But let's first understand what is regression, what are the steps to do regression in Excel, and then fundamentally develop that understanding for our first algorithm so that we can do the subsequent algorithms much more easily. Shall we get started? Okay. All right. Now, when you have to find or do regression, there are certain steps involved. And you need to follow these steps. Right now, don't do it. Just observe what I'm doing. I will give you a data where you can repeat all these steps and you can tell me the predicted value. But as of now, just observe what is happening, what is the process, what is the trend line, what is R square. We will discuss some mathematical parameters, but those will be very, very interesting. It will help you understand how math actually works. Shall we get started? All right. So step number 1, which you should always follow, is select your data and visualize your data. See the trend of how your data is behaving. Now, in order to visualize, I'll click on insert, and probably the best plot here is scatter plot and scatter with smooth lines. I repeat, I select my data, step 1, visualize the data, go to scatter plot, select scatter with lines. Now, before getting into regression or before getting into the algorithm, there's a manual step important, and I'll prove it to you later. Okay, this manual step is so important. And what is that manual step? Before formula. So before formula, the manual step is, as an individual, I will look at this graph and comment in my head, what is the relationship between X and Y? In the sense, What do I observe? What happens to y when x is increasing? Tell us. That's correct. So is it increasing trend? Is it decreasing trend? Is it a linearly increasing trend, linearly decreasing trend, etc., etc.? We start taking notes. Okay. Look at this graph. What do you think happens to y in general when you increase x? Does y decrease over the period of time? It is increasing. As x increases, y is also increasing. These are all mental notes. I'm just taking my notes so that I'm able to interpret the equation and the relationship much more accurately. So in my mind, I look at this graph and I say there are variations, but in general, as x increases, y also increases. Notes close. Step number 2. This is the time when I will ask Excel to run regression as an algorithm. Remember, you can run these algorithms anywhere. In Excel, the only algorithm of AI that you can run is regression. But regression can also be run in Python, in DataIQ, in Stata, and all the other tools that you would see, because it is one of the most fundamental algorithms that you will see anywhere. Of course, in Excel, you can't go beyond it. For example, logistic regression, decision tree, and all that, you can't run. That's why we need advanced AI tools. But right now, I go to step number 2. I will ask Excel to run regression. Let me show you how to run regression. Now, what I will do is I will right click exactly on the curve, and there is an option called add trend line. Has anyone seen this before? Yeah. Now you click on add trend line. Okay. And I scroll down all the way, and there is display equation on chart and display R square value on chart. Just hold on here. I'll explain everything. Now, that's all what I wanted, right? I wanted a relationship between X and Y. But before that, let's question some of the things here. Please don't do it. As I said, you will get an opportunity to do. Understand this first. As soon as I asked Excel to add a trend line, what did you notice that got added on the graph? Dot, sort of a line, which is there on the graph. Now, here's the question to you. Can you explain it to a layman? What is that dotted line? No mathematical terms you can use. You can't use any mathematical terms, but still you have to explain it to a layman. How do I explain where did that dotted line come from? Can anyone attempt? Think. No maths. Simple English. Can anyone explain? Yes.
How accurately solve the formula.
Okay.
That is the answer we might get. So
Interesting.
from the actual line.
Interesting. I'll reserve that answer. Partially right, but partially something needs to be clarified. Anyone else would love to see some views? How would you explain this dotted line to a layman? Someone is asking, where did this line come from? What is this line? Dotted line. Yes? You're explaining something, put it in words. You can try. Louder. Give it a shot, no problem.
It's like from the starting point to the end point.
From a line from start point to the end point, but there would be many routes to it.
What happens, right?
Yeah. Okay. All right. Interesting thing. Anyone else?
Can it be the prediction to the original paper?
Prediction to the, but see, the prediction can only happen if I increase the days, like for 10, 11, 12. And for that, there is nothing. It is on the existing data. Good thinking. That is in the prediction. It's not the prediction because it is for the exact given number of days.
So it's basically a guess.
That's very close. That's very close. I'll also listen to online. Yes, sorry, tell us.
I'm saying that it's basically a guess. They're trying to guess based on this line.
Interesting.
Yeah.
Okay, thank you. Can you repeat your answer? Yeah. interesting. So she says, so she says that a dotted line would sort of represent a perfect relationship if at all it existed between X and Y, which is also very, very close to the actual answer. Now, let me tell you what is that dotted line from a non-mathematical perspective first, and then I will tell you.
Growth of sales.
Sorry?
Growth of sales.
Growth or trend of sales, which is also very close, right? Now, let me tell you how to think of this dotted line. Now, this dotted line is the closest line possible ever to your actual data. Let me repeat. The dotted line is the closest line ever possible to your actual data. Now, what do I mean by closest line? Do you see some gaps between the dot line and the actual line? There is a gap here, there is a gap here, there is a gap here, there is some gap here, there is some gap over there. If you add all the gaps, this is the minimum possible gap ever that can happen to your actual data, which means transforming again to a layman's language. There is no other dotted line in the world which can come more closer to your actual data, which sort of matches all your answers. So you said perfect relationship between X and Y. If at all there was a perfect relationship, it would look like this. It shows the trend on how X and Y behave as they go. All your answers are correct. But technically speaking, in a layman's language, it is the closest line ever possible to your actual data. Now, if you go to the math of regression, which I don't want you to go, you're not doing PhD, but you can actually think how the math of this would work. If you add all the gaps, okay, and if you see the gaps, basically, I don't know if you remember your +1 and +2 mathematical textbook. If there are 2 points, x1, y1, and x2, y2, and then the distance between the 2 points is y2 minus y1 whole square plus x2 minus x1 whole square. That was the Euclidean distance, if we remember long, long back. This is that. All the Euclidean distances are added up and minimized so that the gap is as close as possible. But we are not bothered about the math. What we need to know is this is the best fit line. This is the closest line for your actual data, and there is no other dotted line in the world which can get more closer to your actual data. And once regression finds that line, it gives you the equation of the line. Once you get the equation of the line, problem solved, put any value of x, get any value of y. Let's do that first. Let's see what the prediction is. So to see your guess. So I have the equation with me. For which day were we predicting? Day 9. So I would say equal to 3.8214 times x, which is 9, plus 0.4286. 34.82. So someone said 34 actually. Yeah, so very close. 34, 35 is the predicted value for day number 9. Few more things before you start experimenting. There is one more parameter on your screen, which we haven't discussed. R square value, which is 0.9831. Here is an opportunity for you, especially those who have taken the other module. Can you explain how do I tell a layman what is that 0.9831? What is R square? Is it good? Is it bad? How do I interpret 0.9? Interesting. Actually, it's the opposite of that.
How accurate?
Sort of how accurate this is. But remember, we do not use the word accuracy for R square. Now that you know what the dotted line is, you should be able to tell me what is that R square is.
Difference between the actual data.
That's correct. That's correct. Now let me explain. When you say R square is 0.98, you know what you're actually saying? The dotted line is 98% closer to the actual line. And do you think this is good or bad? 100% good. No, it's just 2% difference, and it's a great trend line to believe that your equation is correct. Now, let me tell you the biggest problem in AI, the biggest problem in history is people ignoring mathematics. And let me tell you where you will fail. There will be a chance when you run regression, the algorithm will never say that this is a horrible prediction. The algorithm will never say, sorry, the data is so bad that I cannot put an equation. Whatever data you give, it will give an equation and it will say X and Y are related like this. And you would say, wow, I got the equation, put the value of X, do the predictions and go on. And on many occasions, people ignore R square. Now imagine if the R square is 0.5, it will still give an equation, something X plus something Y. But it also is telling you that R square is 0.5. Can you tell me what does that mean? 50% difference between trend line and the actual data. And now you as an analyst will question that. You would say R square is only 0.5. Do I trust that equation? Never. I would never take an equation where R square is 0.5. But remember, in all the tools, it will run it. It will never say it's a bad algorithm or it's a bad fit and I cannot plot the equation. It will give you the equation. It will also give you R square. And if you don't understand what R square is, you would say, oh, I got the equation, put the value of X and get the value of Y. In fact, I want you to see R square in action right now. Okay. See what happens when I change the data points. Let's say instead of 19, here there was 38. Look at what happened to R square. It went down 0.69, which means only 70% closeness between trend line and actual data. Let's disturb more data points. Let's make it 21. Let's make it 35. Have a look. In all the cases, it is still giving you the equation. And that's the problem of AI. It never says it is wrong or I cannot run it. Whatever crap data you give, it will run it. It will give you the equation. Now, a person who knows math will say, look at the R square in this case. It is 0.03, which means only a 3% fit between trend line and the actual data. In your worst of the nightmare, you would never consider this as a legitimate equation. So I would disregard it. But someone who doesn't know R square would say, oh, I got the equation between X and Y, put the value of X and get the value of Y, which is why that is very, very important. Next, let me tell you, in which cases were you able to solve on your own? You remember the first data? What was the first data? 2, 4, 6, 8, 10, right? Now see what happens to R square. So when I do 2, 4, 6, sorry, and our original data was this. What happened to R square? 1, which means 100% fit between trend line and the actual data. And that's why you don't see the trend line. The dotted line is actually on top of the actual data, which means there is a 100% match between trend line and your actual data. In such cases, human mind is capable of getting the equation. So you are able to say y equal to 2x. Let's try for the other one where you gave the equation 2x plus 3. Let's try that. So if it is 5, 7, let's make that data. There you go. Again, R square is 1. Perfect. R square, perfect trend line, perfect data, perfect equation 2x plus 3. So wherever R square is 1, which means the actual trend matches what is there in data, human mind will be able to come up with the equation. You don't really need regression, but in any other case where the trend line starts deviating from the actual data, that's when you need regression, and that's where we deploy this algorithm to find the relationship between X and Y, to observe the R square. Don't ignore the R square. If R square is bad, yeah, I will do it, but I will not use it for predictions. I will say this is a bad equation. And as and when we progress in today's session, you will see there are ways to deal with a bad R square. If you get a bad R square, it does not mean that I'll stop doing. You explore few other ways by which can I make a better R square and accordingly change the equation, accordingly use it for predictions and forecasts. Okay. Ready to try one small data set on your own? Let's go for it. So let's download the data first. So in week 4 folder, you will find an Excel sheet called basic data, the first one. Basic data.xlsx, not long data, not data, basic underscore data. That's the file I want you to open. Everyone has access to this data? Yeah. Same
Yes,
case,
sir.
there are some days, day number 1 to 30. There is some sales. Your question is very simple. Give me the predicted value for day number 14. Let's get started. Follow the steps. Select your data, go to insert, go to scatter plot with smooth lines. Make the graph first, observe the graph, then right click, add trend line, right click exactly on the curve. 32.9. Okay. Others, select your data, only the numbers all the way from 1 to 31. And go to insert. I can show you the options so that you don't get confused. Scatter plot and the second one, which is scatter with smooth lines and markers.
So, on right, hello.
Go ahead, please.
Yeah, so when I clicked, right clicked, I cannot see add trend line
Yeah, that's because you're not doing right click exactly on the curve.
on the, okay, okay.
Yeah, just right click exactly on the curve and you'll find add trend line. Anyone else? Or any other prediction? Same. 32.9. Okay. And what's the R square? That
0.99.
so 99%, which is good. Okay. Others keep trying, then we'll do it together, and then I'll show you a surprise. Sorry. No, the first data, basically. In the data. Middle? While learning, okay.
Yes.
This side, 32.9.
Yeah.
Lights. All good? That's correct. That's I'm coming to that. So, at 29, you will do that. Just like 9 and 9, plus so manually. All good? Okay, everyone, for the interest of all, I will do step by step again. In case you missed it, please do it with me. So, yeah. All good? You have the data with you? fine. Just give me a minute, I'll check. It's okay, calm down. All right, so let's do this step by step. Let's select the entire data. And tell me the next step. What should I do? Insert, yes. Scatter plot. Scatter with smooth lines. Okay. Now, everyone, please pay attention. I'm not sure if all of you followed the mental notes. Do you think this graph is potentially any different from a mental notes point of view compared to the previous one, or is the same? Almost the same. As x increases, correct. As x increases, y also increases. So fairly, I'm looking at a linear sort of distribution. Now I right click and add trend line. And I click display equation on chart, display R square value on chart, and that's the one that I want. Okay, now everyone be careful here. Few things that you need to notice. Number one, I would first check R square and then I would check the equation. Okay. I would first check, does this whole exercise make sense? What is the R square here? 0.9948. And I will repeat, this means the closeness between the trend line and the actual data is how much? 99%. Good news or bad news? Good news. Also, I can trust, very easily I can trust, I can use that equation for doing forecasting, which means I can put the value of X and get the value of Y. What's the value of X that I'm trying to put? For which day am I trying to predict? 14. All right. So what I can do is use any space in the sheet. I can put an equal to sign 2.1209 times 14, which is X, plus 3.2308. And that would give 32.92. That's method number 2, which I'm coming to. Yes. Now everyone pay attention. Has anyone not got this so far? Let me know. Want me to repeat? All good? Okay. Now please listen very, very carefully. This is exactly what I want you to understand from tools perspective. Aisha, just 1 minute. Need any help there? Okay. Now have a look on another way to do this. So everyone pay attention. Now you say, well, I invested a lot of time. I did a graph first. I did mental notes of that. I said as X increases, Y increases. Then I did trend line. Then I did equation on chart. Then I did R square value. Put the value of X and got the value of Y. So there was a series of steps involved in this whole process. Probably takes you 10 minutes to get everything done. Now someone else comes in and says, why are you doing all this graph? Regression is such a fundamental algorithm that all the tools are anyway using it by default. I say, what do you mean? And this is exactly the answer. You don't need all this. You don't need graph. You don't need equation. You don't need to put the value of X. All what you need to do forecasting is this. Have a look. Just select your data and just drag it one down. You get exactly the same answer, 32.92. And imagine how much advanced Excel also has become, that when you drag at the back end, it is doing regression automatically. It is putting the value of X as 14 and it's giving you all the results that you need. And now there is a big question mark. There is a big question mark. Why do you need to know the longer method if dragging can give you the answer?
Because to make
It's
it
okay.
the
Sorry.
credit for a lot of values.
That's one. That's good. So let's say if you want to predict it for day number 5,000, right? So then the only way right now is you just keep on dragging all the way till 5,000 and get the answer. So that way, yes, I agree. Definitely for larger values of X, then formula is always something which is important. But I want to prove today that even for smaller values of X, what happens when you don't break the black box? And what do I mean? You don't break the black box, which means you don't understand the math, you don't understand the formula, you don't understand R square, and you say, well, I can just drag and get the answer. Why do I need to know all this drama? Is what I'm going to prove in the next exercise. Shall we do one more forecasting thing? Pretty much similar, slightly different data. Okay, let's do this. And for the next one, I want you to try both the methods. I want you to first try with the original method, which means do the graph, get the trend line, get the equation, put the value of X, get the value of Y, and then also try the dragging method and see in which case what difference does it make? Only some decimal values or bigger difference? You need to tell me. Now, where do you find this data? In the same week 4 folder, there is longdata.xlsx. Long data is the one that you'll be downloading. And let's open this and let me tell you what you're doing in this data set. Is everyone ready with the data? Okay, here is your task. You have 24 days of data. I want you to good ringtone. Oh, that was a game. I thought that, yeah, the ring. You were playing a game or was it? All right. So you have 24 days of data and you want to predict or you have to predict for 25th day by both the methods. Dragging method and the other method. Okay. Can I see that? Okay. That's pretty quick. By both the methods. Try both and find the difference. How much of a difference does it cause in both the methods? Something is wrong. Why did 34 only for the next? So it's given only till 24. Only till 24. Yeah. Sorry. What's the number? 18. 1897. Equation. That much of a difference. No, there's only one. Yeah, then it's fine. Right. Yeah.
Except cost and conditions.
That, what is the difference that you're getting in both methods?
0.962 and 970.
Minor difference. Okay. Again, we'll do this together, but figure out for another 5 minutes. How much? Sorry. Only for 23. You need to correct. Got the equation, yes. Yeah, only for 23 will take. Yes. So probably just make a new. Make a new sheet and copy this. The one where you were getting the graph. Just take out. That 180.
I did this one first, and then I the second remaining blank one.
Okay.
The difference, 0.36 was the normal,
Okay.
and then after I added the right method, it came to 0.477.
So minor difference in decimal. Just wait for 2 more minutes and then we just surprise. Hey, money, zero times. All right, so now I want 100% attention, everyone. Please have a look here. Last row, don't discuss because whatever you're doing is absolutely wrong.
What?
Yeah, so that's why don't tell your friends what it is because whatever anyone has done so far is absolutely brutally wrong. And I just told you in exercise 1, I told you that I will prove it to you that dragging method is, it's just like staying out of the black box. You need to break the black box. And the unfortunate part is, all of you knew how to break the black box. We just understood what is a trend line. We understood what is R square. Conveniently, I think everyone forgot R square. What was the R square in this case? 0.43, less than 50%. Less than 50% means I can actually toss a coin. The probability of heads is still 50%, right? So this is almost like you're tossing a coin and you're saying, that's my prediction. It could be this, it could be that. R square is less than 50 percentage, which means 50 percentage of your trend line does not match your actual data. And if it does not match your actual data, how on earth could you believe that the equation is correct? And why did you put the value of x and get the value of y? But forget about all that. Even coming to that part is quite late. Let me tell you a bigger blunder that many of you did, and possibly the blunder that analysts always do is not even reading out the numbers. When I asked you what's the predicted value, no one gave me in words. Everyone was saying 1809, blah, blah, blah. What is that? 18,000, 189,000. What does that mean? And the moment you read, you'll understand already you're doing a big blunder. Let me explain with the dragging method first. Let's do this together. So let's do the dragging method first. Everyone, pay attention. So I have done this. I drag a step down, and very conveniently, everyone said 18097. Great. But have a look at the previous sales data. You started with 10,000 in day 21, then 17,000, then 28,000, then 46,000, and all of a sudden now you're saying the prediction is 17,000, and nothing else has affected sales. There was a clear growth trend and an astronomical growth trend towards the last 10 data points, and suddenly your prediction says 18,000. That itself shows there is a big problem in this. I cannot trust this dragging, and this is the problem with dragging, because at least now you have an alternate method. You can do a trend line, you can see what is R square, but if you don't know anything and if you believe the tools that do the job for you, this is how the tools do the job for you. They assume certain things, they do the dragging, and you would say 18,000, you would report it to your manager, you'll get fired the next day. There has to be some logic, right? 18,000 after 46,000 makes no sense in the trend of predictions, which means time to go back to our method. But the problem is, even with our method, you reported the same 18,000 something. That's because you conveniently ignored R square. And this is a very, very important next 5-10 minutes to understand how to work with data. So let me remove this as of now. Let's go by the conventional method. I select my entire data. I go to insert, scatter plot, scatter with smooth lines. And what I'm going to do is pause for a moment. And this is a big mistake that everyone does. I know what you would have done. Directly right click, add trend line, go formula, do R squared, done. Because you are in a hurry to complete the task. I told you there was a step before adding trend line. What was that step? Checking for the trend manually. And this is where we ignore human intervention. This is where we ignore our observation on data. Now, listen to this very carefully. This graph on your screen is not the same as the ones we have seen previously. The previous graphs were very simple. As x increases, y also increases. Probably you are looking at a linearly increasing relationship between x and y. I look at this graph and I start commenting, and listen to my comments carefully. As x increases, y does not increase so much up to a certain point of time, beyond which the growth of y starts happening exponentially higher as the value of x increases. And this kind of a narration is not what linear is. Linear is very simple. As x is increasing, y is increasing. This is complicated. This is saying that y remains sort of saturated till some point, and beyond the certain value of x, it starts increasing exponentially, which means the first thing that you need to understand, you are not looking at a linearly distributed data. And in the real world data, this could happen. You might not always get linear data. You get all different types of distribution. And this is where manual intervention is so important. You look at the data and say, this is a different game altogether. It's not my typical y is something x plus something and I see the r square. So I need to be careful before I do my predictions. So let's get on. Now I move on to the next step, which is right click, add trend line. And let me put display equation on chart, display r square value on chart. And let me bring this here. And if you click on the dotted line, you will get the options again. Okay. Now, step one, before looking into the equation, I look at r square. And I would say, not that. Yes. 0.46, I would never consider. Till 8.85, 0.8, above 80% is a trustable trend line. Below 80%, I will be doubtful. Below 70, 60%, I will not even consider because there's so much difference between trend line and actual data. How do I trust the equation for any kind of predictions, any kind of forecasting? I would never ever do that. Okay, which means this equation is out of the picture straight away. I'm not going to use this equation for anything. Now, I keep my eyes on the default option, which I assume the data is. You see these options on the right hand side? You see exponential, linear, logarithmic, polynomial. There are various distributions of data which exist. You assume that it is linear and you got a linear equation. But when I made my mental notes, I was very clear this is not a linear distribution. Can you take a guess? Which most likely exponential because you can see the nature of graph also. You can see how log behaves. It behaves like this, which means it initially increases and then saturates. You can see how polynomial behaves up and down. You can see how power. So power and exponential probably come the closest. But in this case, this is a clear case of exponential because in exponential, it grows very slowly and beyond a certain point of time, it goes higher and higher and higher. And that's when you know that, boss, I was not looking at a linear relationship. I was looking at exponential relationship. And this is the problem with tools. This is the problem with dragging. They wouldn't see anything else. They would say everything is linear, just drag it, do the equation, give you the prediction, and you have no other option than to trust that. So let's change from linear to exponential. Sorry. Yep, there you go. Okay, so everyone have a look here. This is what happens when I select exponential. Before looking into the equation, I would first check r square. In some case, I think you would have got 9.9999. In my case, it just rounded off to 1. It's not exact 100%. It is 99.9%, which means your trend line is now almost close to the actual data. And that's the one I will believe in, not the one that I got last time where r square was 0.46. Of course, the downside is the equation has become complicated. It is 0.4632 e to the power of 0.4791x. And that's the value of x that if I put as, for which day were we calculating? 25. So if I put the value of x as 25 over there, then I will get the actual value. Do you want me to put the value of x as 25? Let's see how to do a e function in Excel. So I'll just put an equal to sign over here. And I would say 0.43. Everyone, please have a look here. 0.4362. 4632. Thank you. Multiplied by. Now, e to the power of, which means I can use an exponential function, 0.4791 times x. X is 25. Yep, that should do. So basically e to the power of 2, if you want to calculate in Excel, you just type exp in bracket 2. That means e to the power of 2. So if you type exp in bracket this entire thing, that means it is e to the power of that. So what value do you get?
3,700.
That looks correct. That looks correct. It should be in 70,000 something because last value was 45 something, so it should grow. 70? Perfect. 73,710. I'll put the formula again. There you go. I have added an extra bracket that's not needed. You can just do multiply and exp brackets. Any questions? Anyone needs any help on this? Let me know. All good? Okay, now just pay attention before we go for the break, because after you come back from the break, we are ready for a forecasting challenge. Okay. Now let me tell you the problem with forecasting challenge. Now the doors have opened, which means now you will clearly know that, oh, let me check. So let's say when you started doing the equation, you did linear and r square came out to be 0.85. Okay. If I would not have told you this, you would have stopped. Sorry, yeah. If I would not have told you this, you would have stopped over there. You would have said, oh, linear is good. I got 0.85 as r square. You would have got put the value of x and got the value of y. But now the problems have actually increased because you know I can check other options. Is it polynomial? Is it logarithmic? Is it something else? And especially when you are not able to make up your mind on what it is, you want to try everything, right? And now there are multiple angles of decision making involved. Number one, which distribution do you choose? Number two, do you choose on the basis of distribution, or would you rather see in which case r square is becoming better? Or do you visually see in which case the trend line is becoming closer to the actual data? All options will suddenly increase.
So, but when we drag the data, so like is Excel defaultly goes for the linear?
100% correct. Always it assumes that every data will be linear data, and it doesn't do anything beyond this, and that's the problem. Unless we know that there's now I know there's an assumption linear, so I'll be careful while dragging. But if I don't know, I will say, oh, that's the predicted value, and I'll go with that. So great observation in Excel. When you drag, by default it assumes linear. Now coming back to the forecasting challenge. I will be giving you data, something similar, but the problem is everything looks correct. Now, when you think this is linear, you might say, oh, this actually looks like linear. Then when you try log, you would say this also looks correct. Then when you try polynomial, you say, no, this also looks fit. Now, when everything looks correct, it has multiple r square values. All r square values are also good. Nothing is extremely bad. So nothing comes out like 0.3 or 0.4. When all the r square values are good, when everything looks correct, when nothing comes as a decision making, what would you decide? That is a big challenge. And in the forecasting challenge, every individual can choose only one answer. You cannot say, if it is linear, the predicted value is this. If it is polynomial, the predicted, no, nothing of that sort. In fact, you can even rely on dragging, and you can say, I believe the dragging answer is correct. Whatever method suits, whatever distribution suits, you have to come up with one final forecasted value. However, it's not as easy as it sounds. In the sense, there are few hidden elements. And again, it's an analyst mindset that you need. You need to look at the graph. You need to look at why this is happening. What is this? Can I check this? Can I do that? Can I try this? Observe all the r square value. Do whatever you can in the world, but come up with one final answer. You say, as an analyst, my prediction for the 27th day is this. And you fill in a form where you say for which day you are predicting, what's the value, what's the predicted value, which distribution you chose, and you submit your answer. And once we come back next week, I'll announce the winners. And there is a massive hidden trick in that exercise. It's not as straightforward as just look at everything and find the best. You really need to apply your mind. You can choose any resources in the world that you want. If you want to take help from GPT, go ahead, plug in data. You can do whatever you want. Try anything, everything, come up with one final answer. Are you all ready for the forecasting challenge? Yeah. All right. So let's take a break now. 2:45. We come back sharp at 3. Please come back on time because we'll distribute the data and then start the challenge. Thank you.
Hello, sir.
Yes.
Yes, I wanted to ask you regarding the summative assessment.
Mhm.
I just wanted to ask, there is no deadline mentioned in the module handbook.
Correct. That's because the hackathon will be somewhere around week 7 or 8, week
Okay.
7 most likely. And the final 60% submission is after the end of the module.
And after the end of the module, that would
After the
be
end
in
of the module.
August, I believe.
Or July end or August 1st. Yeah.
Okay. And I had another question.
Mhm.
Uh, no, where can I find the assessment brief or anything like that?
We will be distributing that. So once we talk about each assessment in detail, you will have a
Yes.
PDF document, you will have a marking criteria, everything.
Okay, just one more question.
Yes.
I have checked my my MDX calendar, and it's showing that on July 5th there's a PPT submission of applied artificial intelligence module.
No. Where did you see that?
I can show it to you. I have a screenshot.
No, that's
Just one.
for the previous reset. That's not for this one.
Okay,
Yeah.
okay,
So
okay.
you'll be
All
informed
right.
of all the deadlines. Everything will be in written. Don't worry about assessment.
All right. Okay.
Okay.
Thank you so
Perfect.
much,
Yeah.
sir.
No problem.